In this problem, it says, suppose a student borrowed money from her rich aunt so she could take a European trip. So she's borrowing money. It says she borrowed $1,200, and her aunt told her she could pay it back over time, $200 each month, with no interest. For this problem, use the function a of p to represent the amount still owing after p payments. Answer each question below. So I'm going to start with C here. It says write an equation for this function. So she's going to pay back her aunt. So she's going to start with $1,200. That's how much she's going to borrow. And then every month she's going to take away $200 from what she owes. Every month, $200. $200. Well, we don't know how many months she's going to do this for. So that's why it's the same thing as multiplication. So it tells us that the number of payments is the same thing as the number of months. So I'm going to put P here because we don't know how many months, how many payments she's going to make. So she starts out with $1,200, and then she's going to take away $200 every month from what she owes. Okay, so the reason why I started with the equation is because now I can complete the table by, to find the amount she owes, I could do 1,200 minus 200 and then plug in the payment number. So if she doesn't do any payments, then she still owes $1,200. So in our table here, we're going to have $1,200. So now we're going to go ahead and what if she made one payment? So if she makes one payment, so I'm going to put a P in for one, or a 1 in for P, she owes $1,200, and if she only makes one payment, so we plug in a 1 for P, then she still owes $1,000. So that's what we put here. So go ahead and finish up your table. And now go ahead and plug in, instead of a 1, we're going to go ahead and plug in 2 here. So she makes 2 payments. We multiply first, so this is 400. And 1,200 minus 400 is 800. So then we'd have 800 here. So each time, each payment, the amount owed is going up, or going down by 200. So then we would have 600 here. And then we'd have 400 here, and then 200. So this is saying in 5 months, or after 5 payments, she still owes $200. That's how we interpret this. After 4 months or 4 payments, she still owes $400. Okay, so now we need to graph these values here. So first thing, I need to include a title. So I'm going to have my title be amount owed for the European vacation or trip. Okay, now I need to label the axes. So since the amount owed depends on the number of payments made, we would know that the amount owed is the dependent variable here. So we know that the dependent variable is always the vertical axis, so the amount owed goes here, and then the number of payments would go here. We also know that because in our equation, this one is always the independent variable, so it's always the one that we graph on the x-axis or the horizontal axis, whereas the A, the amount owed, is all by itself here. This one goes on the vertical axis. That's another way we know. Since payments are positive and the amount she owes are positive numbers, I know I'm going to use quadrant 1. So I'm going to use this quadrant right here. Okay, so then I'm going to I'm going to spread this out here just so it's spread out. I'm going to go ahead and count by 4. So every 4, so 1, 2, 3, 4, just so it's spread out, that's going to be one payment. Even though I'm not going to include a half of a payment or anything like that, I'm going to go ahead every 4, that's 2, just so it's spaced out. That's 3, that's 4 payments, that's 5 payments, and that's 6 payments. Okay, so then the amount owed, the most that is owed is $1,200. So I need to make sure that my vertical axis goes up to 1,200. So since there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. There's 20 boxes going up, and I need to go to 1,200. So if I do 1,200 divided by 20, I would get 600. Or 60, I'm sorry. So to get to 1,200 and have this be 1,200 at the very top, I could go up by 60s if I want, and I would reach 1,200. But since I see that these are going up, or going down, I should say, by 200, I'm going to go ahead and I'm going to make every 3 200. I'm going to go by 200s here. So every 3, so that's 400, that's 600, 800, 1,000, and 1,200. Okay, so now I'm going to graph my values here. So at 0 payment, we're at 1,200. So we're going to start here at 1,200. That's how much she owes. And then after 1 payment, she owes 1,000. And then after 2 payments, she owes 800. And then after 3 payments, she owes 600. And then after 4 payments, she owes 400. And after 5 payments, she owes 200. So we are not going to connect the points here, because in the problem it says that she makes payments each month. So she's going to just pay $200 after, or at the month. So in other words, she's not going to pay her aunt after 1.1 months or in 1.5 months. So since we don't need any of these decimal values, that is why we're not connecting these points here. So for part D, it asks if it's continuous or discrete, and we would say discrete because we are not connecting the points, because we don't want to include what's in between, because she's not going to continuously be paying her aunt throughout the month. She's just going to give her the one-time payment. We're going to count her payments. Payments are counted.